Our first presentation is by Chris Chiesa. He's the Deputy Executive Director of the Pacific Disaster Center and the Chief Information Officer of the PDC. He's also the Chair of the Pacific Risk Management Ohana, which actually serves as our advisory board for not just the center, but also our graduate certificate program. We're really delighted to have Chris with us today from Maui to talk about hazard detection and warning in the Asia-Pacific region. Chris?
Aloha. I was in Bangkok last week and I said aloha and one person responded. It was actually Bill Carwile, former PAO director who of course had spent a lot of time in Hawaii. So I taught maybe 50 or 60 people in Bangkok the correct response to that, but I see you already know it. By the way, I spit on my chair, so I hope nobody sits there while I'm up here. I want to thank my fellow panelists who I guess have now dispersed, but I think they did an excellent job of setting the framework. To respond effectively, or I guess backing all the way up, to recover effectively, you have to respond effectively, you have to be prepared. Couple of key points were made about preparedness, relationships, institutional relationships, and so forth, having adequate supplies, 7 days. I want to add another piece to that, and that's to be prepared, you have to have some sense of what you're preparing for, what's out there, what the context is for what's out there, both in terms of hazards and assets. So really talking about some of the information resources and information applications that you should have in your toolkit, I believe, to be adequately prepared, to understand what's out there, monitor what's out there, and then respond appropriately to it. As Carl mentioned, with the Pacific Disaster Center, we're located over in Maui. We have done a lot of work in the region. We really are a global program, but we started in Hawaii and then moved out from Hawaii into the Pacific and into Asia. So you're going to see in some of my illustrations the work that we've done in the region. Many of you actually are familiar, or some of you, I guess I should say, are familiar with PDC, so I don't really have the first couple of slides of who we are and where we came from and so forth. I'll weave that into the story. I should just mention that we are administered by the University of Hawaii, so we're really a program of the University of Hawaii, and we operate under a type of contract or grant called a cooperative agreement. So University of Hawaii is known as our managing partner. Some of the money comes from the U.S. Defense Department as part of their global disaster program. We support the humanitarian assistance mission of the military, PACOM, and other COCOMs like PACOM, SOUTHCOM, and so forth, and you heard some of that language in the opening panel. We also do work for many other organizations, including FEMA equivalents around the world, sometimes referred to as NDMOs, National Disaster Management Organizations. You'll see some of that as well. What we do specifically is apply science and technology information systems for what's sometimes referred to as evidence-based decision-making, bring that body of knowledge, information together to allow people like policymakers or decision makers, could be elected officials, could be governors, mayors, disaster managers, planners, humanitarian assistance organizations, allow them to make the best decisions through a body of knowledge and information. That can include observational systems, so monitoring what's out there in terms of storms and earthquakes and tsunamis. Modeling capabilities, analytic capabilities that help translate some kind of observation into an impact or consequence. So, there's an earthquake. We know the ground shakes. Is that good or bad, or does it impact somebody? Well, not if it's not strong enough, not if the soil isn't a certain characteristics, not if there aren't people there. So we use models that say, given that physical event, given the earthquake, or given the wind from a hurricane or typhoon, we're expecting these types of outcomes. We need to communicate that information. We need to first kind of get the information and then analyze it and send it back out. So we heavy users of information networks. And things happen in places and time, space and time. So we use GIS and visualization systems to represent that. Some of you may remember the old BASF commercials. We don't make this, we make it better. And I don't really mean the better part of it, but we don't operate those. People say, what satellites does PDC own? Well, none. What we really do is bring all of that together in an environment that facilitates and improves decision making. So we're really standing on the shoulders of those that develop and operate those kinds of systems or develop those models, whether it's in national labs or universities or private sector, and bring it all together and apply it for decision making. I've been at PDC for 10 years and involved in various aspects of disaster management for almost 10 years before that. Certainly there's been lots of advances. Most of us carry around devices like this or laptops or other things. My iPhone. Tremendous, communication device, computing device. If you think about the state of the art 10 years ago when I was at PDC or 15 years ago, a lot of EOCs we would walk into, big map on the wall, covered in plastic, grease pencils. So we've advanced collectively from that. But there's a lot of challenges left for disaster managers. And as we move out into Asia and certainly out of capital cities into the provinces, we see the fax machine, we see the plastic covered map. So it's not all equal playing field. This is an actual advisory from 1979, Weather Service Advisory. If you get one today, it looks exactly the same, and that's neither good nor bad. There's a lot of information in there, a lot of accurate information, but you really have to dig through it. And you have to know exactly what you're looking for, and then, again, run to the map, whether it's paper or plastic or electronic, run to the map and do something with it. Tsunami warnings, chock full of information, different format, different pieces of information, earthquake, etc. One thing that all of those are really missing is a risk context. They're different formats, different sources. Computers are pretty good these days at going out to all these different sources and piecing it together. But none of them really tell you as a disaster manager, do I need to take action? They just say something has happened at this location. So again, our job is to help translate that into actionable information. I know that I wasn't able to see who raised their hand, but it sounded like there's at least several first responders in the audience. Time equates to life in this business. So if I can't readily make use of that information, if I can't decipher it, just because it's labeled information, doesn't mean it's useful to me. And again, we're about translating that into useful information. How do we do that at PDC? We put together applications and processes and methodologies to bring disparate information together, generally from authoritative sources or recognized sources, but from different parts of the world. Put that into a hazard or risk exposure context. So now it's not just an isolated event, but it's in some kind of a context. Share that information through different mechanisms. Originally, pagers and fax machines. Now, social media, mobile applications. I'll do a shameless plug for PDC. We have a mobile app on iPhone and on Android. It's been downloaded by over 1.3 million people. So we know we're getting that out there. We use Facebook and Twitter. I think I have a slide on that. We have a number of followers. Incorporate models that I mentioned before to help understand the impact of these events or potential impacts of these events. Bring in socioeconomic data, not just physical structural data. So yes, it's important to know if roads and bridges are open and power and lifelines are open, but it's also important to know what the conditions were and are in those communities to understand their level of resiliency. And as been mentioned this morning, and is ongoing in the state right now, you need to train and exercise these. You can't just wait and break the glass during emergency and open the manual. You need to be using this stuff on a regular basis. So we get involved in a lot of exercises and workshops in Hawaii and around the region. So let me talk a little bit about some of the disaster monitoring and early warning capabilities that the PDC and its partners have developed and utilized. One of our main applications is called Disaster Aware. It's an integrated multi-hazard system, web-based. There's different variations of it, and you'll see that in a couple of slides. Many folk, in fact, it's being used today as we speak in Makanapaheili. Brings these feeds together, applies business logic or rules, if you will. Let's say, don't wake me up in the middle of the night for a 3.0 earthquake in the middle of nowhere, but perhaps if it's a 6.5 or 7 in a populated area, yeah, that one my pager should go off for. So, it helps separate normal events from those that may exceed a threshold, and of course there may be various thresholds from, just like we think about the weather service, there's alerts, watches, and warnings, so we use similar terminology. We bring in those models, integrate them into that environment, bring in historical and risk-based information. Here we're showing, for example, a shake map for an earthquake that happened off Sumatra, and facilitate information sharing. That can be situation reports, damage assessment reports, ground photograph, news clippings, if you will, and promote wide dissemination of that information. Oops. One version of that we call our Global Hazards Atlas. URL is there, pdc.org/atlas. Web-based, no password required, no plugins or anything like that. You go there and you will see what's happening around the globe. Many of those hazards are automated. In fact, maybe I may or may not have a slide on that, but earthquakes, tsunamis, hurricanes, wildfires, among others, are automated. So we're going to global volcanoes, I think are another one, global or national sources, and bringing that information in a near real-time basis. Others are added manually. There isn't a global source for landslides, for example, or a global source for oil spills, or some other types of hazards. Some of our staff enter those. A lot of our users enter it. So there's mechanisms for users of not so much the atlas, but one step above that, and I'll talk about that in a second, but for users to contribute information, declare a hazard, post those products. So it's not just PDC posting it, it's really the user community doing that. Another version of Disaster Aware is called EMOPS, Emergency Operations System. That is a password protected system. It's designed and used by disaster management professionals. Probably most people in this room would qualify for an account on it, would meet that criteria, actively involved in disaster management or actively supporting organizations that are frontline disaster managers. Has all of the data and features of the Atlas, plus has the information sharing piece of it. So representative or authorized users can declare a hazard, declare a disaster, post products. Here we're looking at a storm, I guess that was on the East Coast last fall. Just showing that you click on it and bring up additional information. In this particular case, you may see this graphic one or more times. We sort of design and build once and disseminate different ways. So this particular product you can also access through the mobile app. You can also access through Facebook and Twitter, for example. That little information regional report, that summary information. Users of EMOPS can sign up for email and hopefully soon SMS-based messages, right down to the event type and the geography. So again, maybe you don't need to be woken up for an earthquake in the Indian Ocean, but you do in the Pacific, or a storm in the Atlantic versus a storm in the Pacific. I've already mentioned the mobile app, Android and iPhone version. It has a lot of the same information in the Atlas, designed, of course, packaged for use on a small mobile device, but you can get to some of the very same information. So there we're seeing when Tropical Storm Maria was on the East Coast, you can see it in map form and list form, and then the far right, you can get that same summary information. We do a lot of work to automate that and have robust processes running on servers here in Hawaii and now in the cloud as well, just for redundancy and ensuring information assuredness in the sense of should Maui be ground zero, heaven forbid, things will still be running elsewhere in the cloud. There's a number of hazards that we automatically process. I mentioned those before. We put those into an enterprise GIS environment. That means that kind of things come in from many sources. They go into one common environment, and then they get published out either as information services or brought into applications. So the same information may be visualized differently or portrayed differently because of the nature of the device or the users, intended users or targeted users. But that same, kind of one piece of information and it's the same piece of information goes into our web app, our social media, things called widgets. We have a number of hazard models that we use: floods, hurricanes, earthquakes, tsunamis, and hazardous material. Notice one thing in common with most of those is that they produce some kind of map-like output. Flood model produces that, the blue areas that will be inundated. The models in the middle say these are areas where winds will cause certain damages. Model in the left with the orange and yellow says these are, hazardous levels of gases, of agents. That information from those models goes into our EMOPS disaster-aware environment automatically. Mentioned the social media a little bit. So that same information, in fact, if you look, I don't have a pointer, but second line down, it says Tropical Storm Maria. So remember, you could have seen that information on our web app. You could have seen it on our mobile app. You can now get it through Twitter or Facebook. One of the interesting things about Facebook is it does establish a little bit of a community. So we will get people commenting on what we produce, and we'll even get other people saying, hey, I think I know, I felt the ground shaking, maybe there is an earthquake here. So again, we sort of have people contributing to the knowledge base, if you will. However, right now, mostly we're using social media to push that information out or share that information with people. One of the initiatives under this year's program is really trying to harvest that information, so make use of all of the tweeting and posting. And here's a screen snapshot that looks at, I think it was the word flood, and I think the source was just Twitter. So where users are saying things about floods and some of the words associated with that. And so you can sort of differentiate the geography and the intensity. And so one of our research areas is really, can this be used as essentially another monitoring device? And I was talking to somebody before the event started, saying, well, maybe we can use it to look at power outages, for instance. You know, people probably are going to be tweeting, hey, the power went out. That in a hazardous event gives me some impact of some estimate of what areas are impacted. Hey, they're off the grid. So we'll be working more and more with this and bringing that into our disaster management environment as well. Just another piece of the information puzzle. Lastly, I just want to end with a couple of slides on where we have deployed our disaster aware solution in the Asia Pacific region. So we work with institutional partners, I mentioned before, mostly national disaster management organizations, some regional organizations as well. A few years back in 2005 and 6, after the Indian Ocean tsunami, or as really part of the U.S. government's response to the Indian Ocean tsunami, we helped the government of Thailand and their National Disaster Warning Center. We helped them establish a version of disaster aware, brought in information from global and regional sources, as well as Thailand's government sources, sort of their equivalent of USGS and their equivalent of the National Weather Service. Automated the receipt of that information, processed it according to their decision and response rules. You know, they're Thailand focused, Thailand centric, of course, so they were interested in things that are close to Thailand or affecting Thailand. Most recently, we've worked with the government of Vietnam and their disaster management center in Hanoi, and we deployed a version of disaster aware that we call VNAware. It actually brings in data from their national sources as well, plus has a Vietnamese language interface. So it's not really enough to say, here's a tool, learn how to use the tool and learn how to use English. We now have the interface in Vietnamese, Thai, Spanish, English, of course, and Indonesian, Bahasa. Incorporates data from some of their national databases. So where are their shelters located? Where are their medical clinics, emergency response stockpiles? Incorporates flood forecast, flood model output. So here looking at a flood scenario from a recent typhoon. We're also working with, and I said I was in Thailand or Bangkok last week. I was in Indonesia the week before that. We're working with the AHA Center, ASEAN, Association of Southeast Asian Nations. AHA is ASEAN Humanitarian Assistance Center. So we're working with that center in Jakarta to adapt a version of disaster aware called DMRS, Disaster Monitoring and Response System. ASEAN has 10 member nations, the countries in Southeast Asia. And so this particular application will be kind of an interface between that center in Jakarta and each of the national disaster management offices in Hanoi, in Bangkok, in Manila, et cetera. We were there about 2 months ago as part, well, I think it was actually April 11th as part of the kickoff. And if you recall, there was quite a large earthquake that day. We were literally standing in the EOC. One of the staff members got an SMS from their family who was in Sumatra, and they actually were texting as they could feel the shaking. There was a big earthquake going on. A few seconds later, epicenter pops up and the contours and so forth. I think it was originally broadcast as an 8.7. I think it was later reclassified as an 8.6. And fortunately, the mechanics of that particular earthquake were such that it didn't result in a measurable tsunami or a large tsunami. But if you recall, it's not that much lower magnitude than this tsunami that devastated the region back in 2004. So there was quite a bit of panic in that EOC at that particular time, or concern. Maybe I shouldn't say panic, but certainly everybody was in a state of heightened awareness. And last but not least, I think this is my last slide, we're also doing work with Indonesia's National Disaster Management Organization, whose initials in Indonesian or Bahasan are BNPB, and don't ask me what that stands for, but we'll just say it stands for FEMA. They have their own. They have their own decision support application or early warning application, and you'll see it there, and it is in Bahasa. It is an Indonesian language, and it's developed in an environment that allows this tool or widget in the lower right corner to be popped in, and you'll see PDC's logo in it. So we were able to take what they had already done. They didn't have to redevelop it or throw away their previous investment, but we were able to quickly and easily insert some additional information elements from these different sources. So it was kind of an example of a quick way to help bring their capacity up to a slightly higher level. With that, I'll either yield the microphone, or I don't know if there's time for questions, but happy to do either. Thank you.
I think we do have some time for a few questions. We have some mics here. Could you state your name and the organization you're representing?
Hi, thank you very much. While I notice your maps are probably going to be very useful, I note that in the last noticeable earthquake we had in Oahu, we had no power for 24 hours. In East Honolulu, we had no cell phone service, we had no internet service, we had no power of any kind. And even if you had a generator, you could not receive anything. So I'm wondering how we would access your very useful maps and projections.
Yeah, thank you. That, certainly a good point. Depending on the nature of the disaster, the communications grids may be offline or certainly reduced capability. Same with the internet. Certainly it says, understand your hazard context and be aware of it. So, I think we've all been, hopefully all been made aware or educated that in Hawaii or in any seismically active area close to the ocean, if you feel the ground shake, move to higher ground, for example. Don't necessarily don't be solely reliant on sirens or other systems. Be aware of it. Be aware in advance whether you live in a tsunami evacuation zone. So I would say go to our site now, or go to your yellow pages or front of your phone book and make sure you understand where you live with respect to hazard zones. In many cases, the cell network will come up, or mobile network will not be as dramatically affected as, say, power and landline. So it may be that if you have a smartphone, you might still be able to use our application during that time. But I think you said maybe the cell coverage was limited. So be prepared. Have multiple mechanisms for accessing information, and always have plan A, B, and C. I guess would be my recommendation. Often this information is certainly usable even in the hours or day afterwards, as we're starting to get into the recovery or response and recovery phase. And so again, the power and the internet and the communications will eventually come back online, and so it's a resource at that time as well.
Thank you. Chris, my name's Arthur Ball. I'm a recently retired military officer and disaster management practitioner. You described your plume modeling software, and last year when I was up at PACOM, tools like that were very, very helpful as we looked at the aftermath of Fukushima and our response efforts. But one thing we suffered with was a lack of understanding of any sort of tools that provided similar modeling capability with respect to ocean currents and dispersion of contaminants in the seawater, and what washed up on the shore today in Oregon kind of brings those sort of things to light. Can you comment on any work that might be going on there?
Yeah, thank you. I probably glossed over it a little bit just in the interest of time, but let me go back by stating those models that I showed in every single case are models that are developed by, maintained by, released by other entities, usually with some kind of good housekeeping seal of approval. So it's the FEMA recognized model, or in the case of the plumes, it's the DTRA, Defense Threat Reduction Agency. So what we typically try to do is identify what models are out there, what their applicability is, what their limitations are, and then those that are appropriate we'll sort of bring in-house and either run manually or whenever possible set it up so that it can automatically be run when a certain event would trigger it. So, you know, when an earthquake happens, triggers a tsunami travel time model, it triggers a shake map and so forth. With respect to some of the ocean modeling that you're talking about, we are aware of some. Of course, there's large global, you know, ocean basin-wide circulation models that NOAA has, and I think there are other models, I forget the name of it, but that the Coast Guard uses for localized oil dispersion, for example, as a result of, say, a shipwreck or an oil spill. Those are the types of things that we periodically evaluate, and when we think they're ready for prime time, or when people are asking for that capability to be in, then we'll bring that internally.
Okay, thank you, Chris.